Hello, Dennis Doverspike again. I'm going to be doing another short video. This video is going to deal with research models, variables, path models. I'm doing this video because it seemed a lot of you were confused about independent variables, dependent variables, mediator, moderators. So I hope this helps to clarify some of that terminology and the way we approach models in research methods. It is pretty hot and humid here today also. Even I have my office down in sort of a bunker in the basement, so usually it's pretty cool. But today it's hot and humid, so if I look like I'm sweating a bit, I am. But I apologize for that. But I'll try to make this video pretty smooth and go pretty quickly and get to the basics for you. Okay? So again, our main learning points, we want to make sure you know what an independent variable is, a dependent variable, a mediator, a moderator, and how they fit together in models. So that's our learning point, making sure you know independent variables, dependent variables, mediators, and moderators. There are three basic types of research design we have. We have a lot of additional ones. Of course, we have qualitative studies, postdictive studies, but basically you could think of the true experiment, the quasi or quasi experiment, and correlational or survey research. Of course, in a true experiment, what makes a true experiment is that we not only manipulate our independent variables, but we also randomly assign individuals into groups. No, we don't have to randomly sample people. That's not a necessary condition for a true experiment, but we do have to randomly assign them to the treatments. In a quasi-experiment, we still have interventions or treatments, but the individuals are not well, they're not for sure randomly assigned into the treatments. Usually they're intact groups. For example, maybe we have two classrooms and we give one classroom our training and we don't give the other classroom our training. Or we have two groups of employees in two different plants and we give one plant the training and another plant we don't give the training. So that's a quasi-experiment. The subjects get the treatment because of convenience or whatever the factor might be, but they aren't randomly assigned to the treatments. So there's no random assignment. And then our last type of design here is correlational or survey research. There's basically no manipulation of the variables. Instead, we're just collecting survey data, or we're just looking at correlations between the various variables. At the heart of much of what we do today in terms of research and also measurement, testing and measurement in applied psychology and in industrial organizational psychology is based upon the idea of latent constructs. So our science is very latent construct based, or we'll just talk about being construct based within this class. Note, in some ways, that's sort of a controversial idea, at least if you're a behavioral psychologist or a behaviorist. Until about 1978, behaviorism really dominated in American schools of psychology. But between about 1970 and 1978, behaviorism sort of started drifting away to where it really disappeared from most psychology departments in the United States. There's very few places where people still what we call run rats or train rats. And so behaviorism was replaced by what we call social cognitive models. And social cognitive models, instead of necessarily looking at behavior, often looked at the constructs behind that behavior. Of course, in applied psychology, there's always been this big emphasis on what we call latent constructs. Now, what's a latent construct? Well, a latent construct is simply a hypothesized but unobservable characteristic that accounts for a particular set of consistencies within or differences among persons. A lot of the variables we're concerned with probably in this class are not behaviors. They're not observables. They're hypothesized constructs or latent constructs. So leadership is a construct. Intelligence is a construct. Conscientiousness is a construct. Depression is a construct. Those are all latent constructs. We can't really observe them, but we theorize about them. They fit within some system. And we measure them sort of indirectly by looking at the correlations between other more observable behaviors. Now, we're not going to get a lot into that. Also, in this class, we're not really going to deal with things like structural equation modelings, which might really look more at the relationship between latent constructs. But you should be aware of this idea of constructs, and that much of what we're talking about is latent construct based. Okay, so we're going to start going through definitions. We're going to start with the independent variable. The independent variable is that first variable that in a traditional analysis of variance design, and you've all been through analysis of variance. In analysis of variance design, it's the variable that the experimenter, the researcher, is manipulating. We also often call it the predictor. It's the presumed cause. You know, I sort of hate to get into causation or discussions of causation, but if we look at it as sort of a simple idea, at least causation, we presume that the independent variable is the cause of the dependent variable. The independent variable is independent because it's free to vary independently of the dependent variable. Its variability may depend upon the researcher. So the researcher may actually, or often is actually, manipulating the independent variable. So as we said before, we can have the independent variable can be manipulated. And if we not only manipulate the independent variable, but we also have random assignment of subjects to the treatments, then we have a true experiment. If we manipulate the independent variable, or in some cases we pretend it's manipulated, even though we didn't really manipulate it, but if we manipulate the independent variable and we do not have random assignment, then we talk about having a quasi-experiment or a quasi-experiment. Finally, if we don't manipulate the independent variable at all, we're just collecting data on the independent variable, then we have a non-experimental design, or a cross-sectional design, or a survey. This then brings us to the dependent variable. The dependent variable is the dependent variable because we see it as depending on the independent variable, as being caused by the independent variable. And we often call it a number of other names. For example, we might call it the criterion, or the outcome, or the result. It's the presumed effect. It's presumed to be affected by the independent variable. So again, the dependent variable is what's caused by the independent variable or depends upon the independent variable. Okay, just again to go over some terminology. Another word for an independent variable is an exogenous variable. Another word for dependent variable is an endogenous variable. So especially within path models, you'll sometimes see independent variables referred to as exogenous variables and dependent variables referred to as endogenous variables. So an exogenous variable is simply one whose value is determined outside the model and is imposed on the model. An exogenous change is a change in an exogenous variable. And of course, the exogenous variable then, as a researcher, I might vary it. But other than that, it's not impacted by other variables in the model. And this is basically, in more standard ANOVA terminology, our independent variable. In contrast, our endogenous variables are variables whose values are determined by the model. And these are dependent variables. These are our outcomes. These are our results. Of course, it could also be a mediator. A mediator is often determined by an independent variable, even though it's not our ultimate sort of dependent variable. And that's sort of one reason why we might often refer to these as endogenous variables. Endogenous is really just any variable that's determined by other variables within the model, where exogenous variables are determined outside of the model, or are sort of independent of the model and therefore independent variables. So that's just another name for an independent and a dependent variable, an exogenous variable, and an endogenous variable. Two other variables we should probably talk about: indicator variables. You know, of course, latent constructs are hypothetical, so we have to measure them. We usually measure them through indicator variables or manifest variables. So, for example, we measure intelligence by giving an intelligence test that's composed of different intelligence test items. We measure conscientiousness by giving a personality test of conscientiousnessism, I guess it would be, which is composed of conscientiousness test items. And then we often also have in a model, or we often also include what are called control variables. Control variables are just those variables kept constant by the experimenter. The experimenter can either keep them constant through the design of the experiment, or the experimenter can keep them constant by statistically controlling for these control variables. So I hope that all makes sense. At this point, I'm going to take the simple idea of independent and dependent variables and start to make a more complicated and more interesting model, one that starts to look more like a grander research idea, by introducing the idea of both mediators and moderators into a relationship between an independent and a dependent variable. So that's what we're going to be doing. We're going to be introducing the idea of mediators and okay, so here's a very basic model that's attracted a lot of attention over the years. It's certainly not a true or even a quasi-experiment. It's basically correlational or survey or often cross-sectional data. Although we could, of course, have a predictive design here or a concurrent design, but right now we won't get into that. But it's a very basic model of college prediction. So we have two variables, and we argue that one is the independent variable, and that's our score on some sort of college entrance exam. Let's use the SAT. And that's used to predict, or it's said it might cause, your college GPA. And we know that correlation is around 0.30. But that in and of itself isn't that really interesting of a model. I mean, although there's been a lot of research on it over the years, meta-analytics studies, it's pretty basic. There's one independent and one dependent variable. We calculate a correlation or a Pearson R. You know, the typical Pearson R is around 0.30 for this basic model, this basic relationship between one independent and one dependent variable. And of course, underlying this, though, is a construct model. Even though we're looking at the relationship between SAT and GPA, we often see SAT and GPA as representing higher level constructs. In this case, the higher level construct that the SAT is measuring might be general mental ability, and the higher level construct that the first year GPA is measuring is college performance as an overall criterion. And then what we're really interested, of course, is the relationship between the two latent constructs, general mental ability and college performance. Of course, what we really obtain is the relationship between SAT and first year GPA. But we're seeing the SAT as being an indicator of general mental ability, and first year GPA as being an indicator of college performance. And therefore, we see the correlation between SAT and first year GPA as giving an estimate of the correlation between general mental ability and college performance. Okay, so let's start to make this a little more interesting. So now we're going to put in a moderator. One of the moderators that's been studied a lot over the years, and that's the moderator of race. So we might hypothesize that while performance on a college entrance exam like the SAT is related to GPA, that relationship is moderated by another variable or depends upon another variable, and that other variable would be race. Now, when we say moderated, we mean that the relationship between SAT and GPA either changes direction or changes strength as a function of the race of a group of individuals. So we might, for example, argue, it's been argued frequently, that the relationship between SAT and GPA is stronger for individuals who identify their race as white than for individuals who identify their race as African American. And of course, we can study that, and you can see how that starts to become a more interesting hypothesis, and probably more important than just looking at the relationship between SAT and GPA. So here we're postulating that race is a moderator of the relationship between SAT and GPA. It impacts the relationship such that the correlation between SAT and GPA depends upon the race of the individuals taking the exam. Now, I think in office hours last week, someone actually asked if race could be correlated with GPA. And the answer is yes, it could be. In general, it's probably cleaner if moderators are not also correlated with the dependent variable, but certainly moderators can be correlated with the dependent variable. And also, of course, moderators are really sort of themselves an independent variable. We could probably change this model around if we wanted to and argue that there's a relationship between race and GPA, and that's moderated by SAT. That might not make theoretical sense, but we could do that, I mean, statistically. And probably when you took analysis of variance, you didn't really care about, if you're looking at an interaction, which variable was moderating which. But within our model, here we're postulating that it's race that moderates the relationship between SAT and GPA. And of course, I'm not very good at drawing. I'm terrible. I'm a terrible artist. When I was in grade school, they made me stay in from recess often just to work on my handwriting. And so I'm challenged when it comes to drawing things. But this would probably be what this moderation model would more likely look like. We might even have a little X there where the demographics are. So we're saying general mental ability leads to or causes or predicts GPA, but that relationship is moderated by some demographic variable. Again, from a statistical standpoint, moderation is really just what in analysis of variance terms we refer to as an interaction. It's an interaction between independent or predictor variables. Of course, here's another famous interaction, ability and motivation. So we often hold, although there's some research that might dispute this recently, that ability and motivation interact to predict school performance, job performance, etc. So an interaction and a moderation, statistically, they're the same. Theoretically, or when you think about models, there's some differences. For example, to me, a boundary condition is different than a moderated relationship, and a boundary condition would be another type of interaction, a type of interaction that's not a moderation. But we're starting to get into the weeds there, and we're going to try to keep this simple. Okay, so we talked about moderators, now we're going to talk about mediators. So another sort of famous model is that general mental ability predicts job performance. But again, there's been a lot of research on that. In and of itself, it's not that interesting that general mental ability predicts job performance. But it gets more interesting when we start saying, well, what explains or mediates that relationship? What's in that black box? What's in the black box between general mental ability and job performance that helps to explain why general mental ability predicts job performance? What does general mental ability cause that then that variable causes job performance? And one answer that's been hypothesized, and there's some research that supports this answer, is that it's job knowledge. So this would be a famous mediated model of job performance. It's a general mental ability or intelligence leads to increased job knowledge, and increased job knowledge leads to increased or better job performance. So whereas general mental ability leads to job performance, it does that through the mediator of job knowledge. Now, of course, we actually could have full or partial mediation. That is, all of the effect of general mental ability could pass through job knowledge onto job performance, or only part of it could pass through job knowledge. There could be also a path that goes right from general mental ability to job performance, in addition to the mediated path. So you can have full and partial mediation. That's something a little more complex. If you have this kind of model, we might have to talk about that later on. But for right now, this is a basic idea of what a mediated model looks like. Here's another famous mediated model, stereotype threat. We know that providing information, whether it's true or false, on the test medium, even with the same content, leads to differences in test performance, especially for traditionally underrepresented groups. For minority groups, whether it be minority in terms of gender or race or ethnicity. But that leaves, again, a big black box in terms of why is it that the test medium impacts test performance. Again, what makes it more interesting if we start looking for hypothesizing what's the mediating mechanism. And one mediating mechanism that's been postulated is that of test anxiety. So we can have test medium leading to test anxiety, which then leads to test performance. Here's another example of this is from police or criminal psychology or forensic psychology. But a lot of IO psychologists do research with police. And of course, there's been a concern recently with the use of force. And, one series of interesting studies looked at why do police, in some cases, resort to using force when dealing with a veteran who's causing problems, and other cases they don't. And so the basic model was that first a police officer observes a veteran may be engaged in criminal or at least problematic behavior, and then they make a decision, should I use or not use force on that veteran? But what's again the mediating mechanism? And one of the mediating mechanisms that's been found is an assessment of danger. So a police officer observes the veteran or observes the situation, observes whatever behaviors the veteran's engaging in. Then they say to themselves, well, is this veteran a danger either to myself, to other individuals or people, or to themselves? And if the veteran is a danger, then they may use force. If the veteran's not a danger to themselves, others, or the police officer, then they don't use force. So again, just an example of mediation in a model. Here's a model that includes both mediation and moderation. So we can go back and we can take our model where general mental ability leads to job knowledge, leads to job performance, or is mediated. The relationship between general mental ability and job performance is mediated by job knowledge. And now we can throw in a moderator, some demographic variable. Again, it could be gender, it could be race. We put it into the model. It's interacting or moderating both relationships. So the demographic variable can be moderating the relationship between general mental ability and job knowledge, and also the relationship between job knowledge and job performance. And so this is a model that has both mediation and moderation. And here I've sort of drawn, again, I tell you I'm not very good at drawing, but here I've sort of tried to draw it out with X's to indicate where the interaction occurs. That brings us to the end. I hope you've learned something about independent variables, dependent variables, mediators, and moderators. I hope this helps you with coming up with your own model. It's a good idea to sort of try to visualize your model by graphing it out. If you have questions or comments, please use Ask the Instructor or bring them to office hours, I'll be happy to answer them. Again, I hope this has been helpful, and that brings us to the end. Thank you very much.